Once again, all of you welcome to my YouTube channel. Today topic is electroendosmosis. So this is the major important factors which affecting rate of mobility, and also it significantly affects the rate of migration of the molecule, especially proteins, the DNA under the electrophoresis. So how it affects? What are the phenomena it's happening? So how it works? So a lot of details we are going to see. Please let's go. So electroendosmosis is the type of osmotic process especially taking place at the inside of the gel and also based on the applying voltage. So when the applying voltage is called electro, and also the osmotic process takes place in the inside of the gel, and the process called osmosis. So this is collectively called electroendosmosis. But we are going to see the two types of electroendosmosis. We can learn one by one. First, we take a first part of electroendosmosis. So you know very well, across electrophoresis or SPH are very versatile technique for separation of molecule. So that time we are using some stabilizing medium. This medium is very important for us because this is the only part of the electrophoresis we can identify and we can manipulate and further also. So and also we are placing the sample at the stabilizing medium. So the migration takes place in the medium. So a lot of events are takes place, and that's why this stabilizing medium is more important than the buffer, than the voltage, than the other parameters. Okay, we are routinely used in gel. Yes. The first part of electroendosmosis is in the gel as well as surface of the separation equipments. Gel as well as surface of the separation equipments such as glass plates, tubes or capillary tubes or other apparatus we are using the electrophoresis. So those separation equipments containing the surface containing some functional groups. For example, if you are using the glass means the glass containing silicon oxide. Suppose we are using across as a gel matrix, the across pore contains sulfonic groups or sulfhydryl groups. Yes. Suppose if we are using starch as a separating medium, the starch pore surface contains carboxylic groups. So these groups are already exist and fixed in the surface as well as inside of the pore. Okay. So these groups get ionized. Uh, ionized These groups get ionized when we are adding or placing the gel into the buffer, either basic or neutral buffer. So those groups are get ionized. That means those groups are donate the H plus ions. H plus ions, especially carboxylic group and sulfhydryl groups are silicon oxide. Okay. So this ionization, the group get into carbonated ion, sulfhydryl ion, or silicon oxide ions. Okay. Thus, in the electric field, they will be attracted by the electrode. Okay. So after ionization, the group get donated the H plus ions. Once it's carry the negative charge. So the negative charge always attracted by the anode, because we are already run the gel between the cathode and anode. The direction of migration always cathode from anode. So the anode to attract these functional groups ions, but those molecules are fixed on the surface or in the matrix. Suppose the sulfhydryl groups or carboxylic groups are fixed in the matrix. Silicon oxide groups are fixed in the glass surfaces. So it can never migrate But even though the anode will attracted the ionized ions, so it's look like a propagated group. Yes, okay. So this propagated group, carboxylic group or sulfidal groups, may be present in the inside of the pore, surface of the pore. So this propagated groups will significantly affect the rate of migration of the our given molecule, either DNA or protein. Yes. So these are deals with the electroendosmosis one. Okay. 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 This good. Okay. Electroendosmosis EEO is a functional parameters which affect rate of migration, and also number of these groups are significantly affected, especially sulfate or pyruvate group present in the across polysaccharide, and also those groups are collectively called anti-convective phenomena. Yes, but they are fixed in the surfaces or inside of the pore. So next we can very detail through the picture. So this is the image will intimate. Okay, this is a picture we can easily understand. Here two pictures there. One is electrophoretic migrations always take place like this, from cathode to anode. Cathode to anode. Yes, okay. Okay, this picture will clearly mention this is the rate of migration of the electric field. Yes, and also electrophoretic migration. This is always takes place in the cathode to anode. Cathode to anode. Yes. So this is the considered as a gel matrix. This is the considered as a gel matrix. So the gel matrix contains some functional groups. Some functional groups. When it's get ionized, it 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 propagate the anionic nature. It's always attracted to the anode. Okay. So here clearly indicate this is the carboxylic group. The carboxylic group may be, if you are starts as a medium, the medium contains carboxylic group. Okay. Suppose if you are using agarose, the agarose containing sulfhydryl groups, sulfhydryl groups, and also the glass surface will produce propagate psyllium oxide groups. So those groups are significantly affected when the DNA or protein migrated in this pore. Yes, okay, in this pore. Okay, this is the it's called electroendosmosis one. Yes. Here, very clearly indicated is this is sulfhydryl group. Suppose we are in agarose, and also some sodium ions are move oppositely. This is called another type of electroendosmosis. We can study later. Okay. Suppose if you are using starch, the carboxylic group as a fixed group, when it's ionized, if the group may be placed in the buffer, get ionized, but is always attracted to the anode. Yes. Yes. Okay. This is the electroendosmosis 1. Now, electroendosmosis 2. This is the very interesting phenomena. It's happening. How means When we are applying the electric field into the electrophoresis apparatus, some of the hydrated positive ions are formed. How it's formed is, that means, suppose if you are taking consider as electrophoretic apparatus, this is the cathode, and also you are giving voltage is working. When the voltage reaches to the electrode surrounding water molecules, or the water molecules attached to the electrode, first get hydrolyzed. Hydrolyzed. Suppose you know very well, when the water molecule is hydrolyzed, what's happening? So the water molecule will produce H plus ions and OH minus ions. Yes. Suppose the water is hydrolyzed. The water was hydrolyzed by the applying voltage. So these ions are collectively called hydrated positive ions. This is the hydrated positive ions. Yes. Okay. This hydrated positive ions based electroendosmosis is called electroendosmosis type 2. Yes. Or second mechanism which involved in rate of migration. Okay. But this hydrated positive ions are easily migrated because it's not attached, it's not associated. Okay, but the surface containing gel matrix containing hydrated positive ions are associated with the fixed to the surface or gel, but it never migrate. It's never migrated. But in the case of this H plus hydrated positive ions are not in the fixed, it can easily migrate to cathode. Migrated towards cathode. Yes. This hydrated positive ions will cause some ionic clouds. So the hydrated ionic clouds are created at the cathode side. Yes. So these clouds easily attracted by the cathode. So this hydrated cloud ions are migrated to cathode. So that time the direction of migration of molecules oppositely migrated. So that time the hydrated ionic clouds are migrated oppositely. So this opposite migration of hydrated ions, positive ions, will give some resistance to the migration of our sample molecule, because sample molecules are migrated cathode to anode. This hydrated positive ions are migrated uh, cathode. So both migrations are oppositely oriented. So this will cause some retardation. Yes, retardation. Okay, this is called electroendosmosis 2 phenomena. Yes. Okay, here once again I clearly mentioned the several gels means like a polyacrylamide gel, acrogel, starch gel, cellulose, whatever it is, are routinely used for electrophoresis for corresponding separation of corresponding molecules. So at the time of electric field application, some positive ions are form. These positive ions are will create a positive ion clouds at the cathode side. At the cathode side is here. Number of H plus ions are produced. These ions are produced from hydrolysis of water molecule. Hydrolysis of water molecule. Okay. These ion clouds are moved in the opposite direction to the cathode. Yes. This phenomena is called electroendosmosis or endosmosis. That now we are going to what is called osmosis means. You know very well. Osmosis means migration of solute molecule, migration of solute molecule from lower concentration to higher concentration across the membrane, across the semi-permeable membrane. So once again I am telling the migration of solute molecule from higher concentration to lower concentration. Okay, the migration of solute molecules osmosis means osmosis means the solute molecule can migrated from lower concentration to higher concentration. Okay, osmosis means the solute molecules always migrated from lower concentration to higher concentration across the semi-permeable membrane. This is osmosis process inversely to the diffusion. Usually diffusion means the solute molecule, high concentration of solute molecule are migrated to low concentration. This is called diffusion, but osmosis is a reversible process of diffusion. So here the solid molecules are migrated from uh, high concentration to low concentration. So please keep in mind this is the H plus ion clouds are migrated to cathode is the osmotic process. Okay, this opposite migration will create a tension. A small type of tension is created by these oppositely moving ion clouds can affect movement of sample of macromolecules. But this rate of migrations more important, more important than the other voltage buffer, nature of the sample, or ionic concentration, um, temperature, and pH. So, electroendosmosis major role, but this phenomena is entirely masked. We cannot easily visible. But you consider that a time of electrophoresis if you are doing. Okay. The migration of some proteins can be slowed. Some proteins can become immobile by this electroendosmosis. So other proteins are pushed towards the cathode. So this proteins are pushed to the cathodes, but it can migrate oppositely. Yes. But it reduce the migration, otherwise called slowed, or some proteins are not immobile. Some other proteins are pushed toward the cathodes, but we never attain the expected resolution of the separation. So please keep your mind. It's a very important phenomenon. Many proteins uh, electrophoresis method take advantage of this tension and use it to achieve the better separation. Suppose if you want get the better separation, you consider this electroendosmosis. If we are using low electroendosmotic medium or matrix, okay. Here example is if you are using separate the gamma globulin in the serum or from urine or other body fluids, uh, you can try to separate. The more sharply by being pushed to the cathode. Suppose this is the good example, the gamma globulin molecules are migrated towards the cathode, but usually gamma globulin migrated to anode, but by the electroendosmosis is oppositely migrated. But that time we cannot never appear the uh, good result. Yes, we never got the good results. Please keep your mind is very important factors. Then how we find out the uh, uh, this electroendosmotic process? Okay, okay. This is the another name is called electroosmotic flow. So suppose when we are using the capillary electrophoresis, the famous electrophoresis, if the word is called electroosmotic flow. Suppose if you are using the gel electrophoresis, you call it electroendosmosis. Both principles are same. Both principles are same. Okay. Okay. Now we are going to electroosmotic flow. This is another terminology we are using at the time of capillary electrophoresis. Suppose if you are if you are okay, next we move on to electroosmotic flow. This is interesting terminology we are using at the time of we are running the capillary electrophoresis. Capillary electrophoresis is very famous electrophoresis. Um, Suppose if you are running the capillary electrophoresis, this we are calling electroosmotic flow. Suppose we are doing the gel electrophoresis, we are calling electroendosmosis. Both are same process. Yes. Okay. Electroendosmosis is normally seen the negative effect, yet a free electroendosmosis is a normally seen as a negative effect. Yet a few methods take advantages of this effect to achieve separation or detection of results. Yes. So please keep your mind, it's create negative effects. So in the gel, the electroendosmosis efforts is observed as a water flow towards the cathode. So if the electroendosmosis process is too high, the water flow maybe takes place towards the cathode. Yes, due to the accumulation of positive ion clouds, which conveys also a part of solubilized substances. Sometimes the sample gets soluble, the soluble substance also get migrated towards cathode. So this process are collectively called electroosmotic migration, is directed contrary to the electrophoretic migration. So please keep your mind. This counterflow cause blood zones and also tailing zones. It's caused tailing zone or blood zone, but we cannot never find out the exact molecular weight. Yes. Okay. Then now we find out the amount of EEO. So how we find out the electroendosmosis? It's called minus MR. Okay. Relative electroendosmosis. Okay. If you are measure the electroendosmosis of the gel or glass or electrophoretic apparatus, you can easily find out. How it's find out? Electroendosmosis of a matrix is quantified by the subjecting a mixture of dextran and albumin. Okay. So you can run the dextran albumin as a molecule in the corresponding matrix. So at the time of separation of dextran albumin in the electrophoresis, um, visualizing their migrated zone, after separation, measuring their respective distance from the origin. Okay. Okay, we can take the amount of electroendosmosis calculated by dividing the migration of distance of dextran. So this is called OD. The OD migration of distance of dextran divided by migration of distance of the albumin. Okay, once again we take a migration of distance of dextran divided by the sum of migration of dextran plus the sum of migration of albumin. So finally we got the electroendosmosis, a relative electroendosmosis of the gel. So if the value is very low, you got good separation. Suppose the value is too high, the matrix containing low or huge amount of electroendosmosis factors is there. So please keep your mind. If if the electroendosmosis value is low, so that corresponding matrix are maybe low electroendosmosis. Suppose this electroendosmosis value is high, so the medium containing number of functional groups, so those functional groups are significantly affected by the separated molecules at the time of separation. Okay. So thank you for watching.